Astronomers are finding more super-Earths, which are larger, more common, and potentially more habitable than Earth. Recently, a planet was discovered that is the largest super-Earth ever found, but it is bathed in molten magma and has a very short year. NASA's Transiting Exoplanet Survey satellite discovered two unusual planets in the habitable zones of their parent stars in 2022. One that is 30% larger than Earth and orbits in less than 3 days, and another that is 70% larger than Earth and may have a deep ocean. Super-Earths are planets that are more massive than Earth, but smaller than Uranus and Neptune. Scientists have traditionally focused their search for extraterrestrial life on planets that are similar to Earth, but recent studies have shown that super-Earths may offer the best chance of discovering life on other planets. These planets are more prevalent than Earth-sized planets and are easier to find and analyze. Many super-Earths orbit cool dwarf stars, which are more common than stars like our Sun. Tens of billions of super-Earths may exist in the Milky Way alone, with potentially habitable regions where liquid water can exist. Two techniques are used to detect exoplanets: gravitational pull and observing a star's light as a planet passes in front of it. German philosopher Gottfried Wilhelm Leibniz claimed that this is the best of all possible universes more than 300 years ago. However, contemporary astrobiologists have focused on what makes a planet habitable to life and have found that the Earth is not the ideal place that could exist. The Earth's long-term habitability was a result of chance rather than predetermined. Researchers have identified characteristics that make a planet favorable for life, including larger size and geological activity. The most habitable planet would be 20 to 30% larger by volume, have twice the mass of Earth, an average temperature of 77 degrees Fahrenheit, and shallow waters for light. Super-Earths are exoplanets larger than Earth, but smaller than ice giants like Neptune and Uranus, and can be composed of gas, rock, or a combination of both. These planets are more likely to be habitable if they have characteristics such as being between 20 to 30% larger than Earth, having a denser atmosphere, geological activity, and orbiting an older star with a powerful magnetic field. While super-Earths are not necessarily similar to Earth, they are more prevalent in our galaxy and have been found to be potentially highly livable. Super-Earths can be up to 10 times as large as Earth, and there may be a range of planetary compositions in the mass range of 3 to 10 times that of Earth. Some of these planets are called Sub-Neptunes or Mini-Neptunes. In 2019, NASA's TESS discovered a super-Earth and two Mini-Neptunes orbiting a cool, dim star 73 light-years away. The innermost planet, TOI 270 bits, is probably a rocky super-Earth approximately 1.9 times bigger than Earth. The other two planets, TOI 270c and d, are respectively 2.4 and 2.1 times larger than Earth. Super-Earths, which are up to 10 times the size of Earth, have compositions dominated by gases and may weigh about 5 to 7 times as much as Earth, making them Mini-Neptunes. The discovery of Mini-Neptunes and nearly Earth-sized planets in the TOI 270 system may provide insights into the formation of these planets. While the surface of Planet D may be too warm for liquid water, further research may reveal more rocky planets that could potentially support life. Recently, exoplanets that have been ejected from their star systems have been discovered, which may be able to support life for tens of billions of years. A newly discovered exoplanet located 200 light-years away could help solve one of planetary science's greatest mysteries. The exoplanet known as TOI 1075b is one of the largest super-Earths discovered so far, with a radius 1.8 times that of Earth and a mass nearly 10 times greater. It is located in the small planet radius gap, a region deficient in planets between 1.5 and 2 Earth radii. It has a high density, suggesting it is likely rocky, and is a good candidate for testing theories of planetary formation and evolution. The small planet radius gap was only discovered in 2017, when there were enough exoplanets to discern a trend. TOI 1075 bits is a super-Earth exoplanet that is one of the largest known, with a radius of 1.8 times that of Earth and a mass of 9.95 times that of Earth. It is located in the small planet radius gap, which is an area deficient in planets between 1.5 and 2 Earth radii. The prevalent theory for the lack of planets in this region is that smaller planets lack the mass to maintain an atmosphere against evaporative radiation. TOI 1075 bits was discovered using data from NASA's TESS telescope, which searches for dips in starlight caused by orbiting planets. The planet's large atmosphere is predicted to be made mostly of hydrogen and helium. TOI 1075b is a super-Earth exoplanet located in the small planet radius gap, with a radius of about 1.8 times that of Earth and a mass of 9.95 times that of Earth. It is a rocky planet and about twice as dense as Earth, with no evidence of a hydrogen-helium atmosphere. Its composition and extremely short orbital period suggest that it could have either no atmosphere, a bare rock surface, or a metal silica vapor atmosphere. Its discovery provides an opportunity for testing theories of planetary formation and evolution. TOI 1075b is a super-Earth exoplanet located in the small planet radius gap. It has a radius of 1.8 times that of Earth and is 9.95 times more massive. Its density is about twice that of Earth, which is strange because exoplanets in the radius gap are expected to have sizable hydrogen-helium atmospheres. TOI 1075b's proximity to its star means it is incredibly hot, possibly even hot enough to have a surface ocean of magma that generates an atmosphere of evaporated rock. Astronomers plan to use the James Webb Space Telescope to determine whether the planet has a silica atmosphere, a thin atmosphere, or no atmosphere at all. This information could reveal previously unknown aspects of planet formation and evolution, as well as how super-Earths lose their gas. The James Webb Space Telescope will aim to study 2 potentially habitable super-Earths in its first year of operation, as well as other super-Earths with large oceans. Ground-based telescopes currently under construction, such as the Extremely Large Telescope and the Giant Magellan Telescope, have high prospects for discovering signs of life in exoplanet atmospheres by the end of the decade. Scientists are aware that the essential components for life exist in the universe, but until evidence of life is discovered elsewhere, it remains uncertain whether Earth's life is unique. The search for signs of life on super-Earths will continue, and the outcome may reveal whether the universe is a lonely place. Astronomers are constantly searching for exoplanets that could potentially host life, with the James Webb Space Telescope and upcoming ground-based telescopes being crucial tools in this search. While the discovery of essential components for life in the universe is promising, the search for signs of life on habitable super-Earths is ongoing, and the possibility of a lonely universe remains until proof of life elsewhere is found. So that's it for today's video. I hope you like it. If you really, then do not forget to subscribe to our channel and hit the bell icon for more videos. Thanks for watching and have a wonderful day.